Great. Well, thank you everybody for joining today's virtual Hyperledger meetup. We have a discussion about multi-enterprise automation with privacy-preserving layer 2 scaling on Ethereum. And today, this discussion is being led by Andreas Freund. Thank you everyone for joining. Again, we welcome your comments, questions, discussion. So please, again, if you have anything you'd like to add or include in the discussion, I think putting it in Zoom chat is probably the best way to get the your question in there into the discussion. And with that, I want to take it away, Andreas.
Thank you, David. Thank you for having me. Thank you for joining. Very much appreciate your time donating your scarcest resource that you have, your time. So next generation ERP, what has that to do with anything related to blockchain, right? Enterprise resource planning. Hold on, why that title? And how is that related to blockchain technology? Isn't that completely different universes? So let me try to answer that question step by step. So in today's enterprise world, service quality is basically constrained by its supply chain. More and more, its digital supply chain. And not only one supply chain, but dozens for large enterprises, because they are comprised of composite services. And that means they need to coordinate with multiple enterprises at the same time. And not only with one, but with several, and not necessarily only in a buyer-seller relationship. As we observe in our daily lives, the services we want and that we're using are more and more real time. That's the demand. So in order to do that, business process execution must become increasingly distributed. Like I wanted like a quick story from this morning. I was yelling at my bank because their online experience looks like, 2012. You can't do anything self-service, basically everything for business banking. Everything needs to be set up, approved. It is just a nightmare. They don't use FedNow, so instant payments. It's like all of this again on demand. That's what people are used to. That's what they want. That's what they will not settle for anything less. So that has to happen. And by the way, newsflash: any blockchain product needs to enable that. If you have a blockchain product that does not deliver a Web 2 experience, your only chance of financial success is playing the token bullshit bingo game. So what enterprises really need, right, is they have to integrate multiple workflows across multiple companies as depicted here, and they need to be kept in sync, which is very hard, right? Because you're going from ordering through delivery and billing, and you have this all happening in silos, not only with one enterprise, but across multiple enterprises. So what is that? So B2B coordination is tangled in a knot of challenges. Silos, manual processes, oh God, right? Data inconsistencies. That's a $3 trillion opportunity cost annually. That also means that digital transformation and moving towards more and more real-time services, also between businesses, is hindered primarily also by privacy and regulatory issues. And just another fun fact is 75% of organizations have these knotted business processes across 2 to 5 business partner processes. So they have multiple processes that are this tangled with each business partner, which is for anybody who has ever done procure to pay knows it's a bloody nightmare. So do existing solutions meet current market needs? No. Why not? Because you have what's called the digital transformation trilemma, right? You need performance, you need the collaboration, but you don't want to yield influence over the workflow, and you have to have security first as well as privacy, right? There are sensitive business information, customer information, right? Currently, you got to pick 2 out of 3. You can't achieve, if you have performance and security and privacy, then collaboration really sucks. So if you have security and privacy and collaboration, then performance sucks. So, go figure. So traditional ERP platforms, which are single business only, I just don't meet just don't cut it. Like whether it's Microsoft, SAP, Oracle, ServiceNow, or even like a blockchain thing like TradeLens. Like the TradeLens has gone the way of the dodo bird. Microsoft, SAP, Oracle, and ServiceNow are doing very well, but anyone who has ever implemented these systems knows what it means when you need to integrate across different enterprises. So how can we actually go about doing performance, collaboration, security, and privacy at the same time? And okay, no question. Just checking. So and this requires a new approach. So it requires zero trust and zero knowledge to untangle these multi-enterprise coordination challenges, right? So zero trust means you need to authenticate and authorize every business transaction anew every single time. You cannot assume that the partner you connected with just a second ago has not been compromised. So that's why you need to, that's what the zero trust framework is: authentication and authorization for every single transaction anew, right? Which is, painful if you're doing it the traditional way. You also need prove and verify. Why? Because you have to have correct business partner process execution every single time. You need to be able to prove that. Why? Because how do I know that what I'm getting for you is actually correct? Even if it's a statement about something, right? Not only is it between a buyer and seller, but the seller got information where they were a buyer and another partner was a seller. So as you go down the supply chain, every single pair needs to basically do the same thing: prove and verify. Why? Because the buyer at the end will have to say, it's like, prove to me that all of this was correctly executed. Case in point, right? It's Chinese steel being relabeled Vietnamese steel and imported into the US. Happens all the time. That's fraud. If you had that, if you knew where all the reports, if you had a digital verification that the execution of those meteorological reports were actually accurate and were verifiably correct, boom. Then you have something. If not, trust but verify, and often you can't verify. So lastly, of privacy, right? So no one wants to share data, so you need to minimize sensitive data exchange and business partner processes, while at the same time synchronizing your processes. That's a challenge. So that's where zero knowledge comes into play, on the prove and verify, as well as on the privacy aspect, right? And how does that work? You can use a zk layer 2 solution on top of public Ethereum, because then you can get enterprise compliant business partner process automation that's scalable, private, does not give you a governance headache, aka who wants to run a private blockchain network. Well, private blockchain is an oxymoron in itself, but it's the whole governance headache is what killed like TradeLens and Food Chain and what have you not. You can establish interoperability. I'll show you that in a second. It's publicly auditable. Why? Because all the proofs of correct execution from the layer 2, like in a zkEVM, are deposited and verified on public Ethereum, which means anybody can verify that whatever happens in the execution environment was done absolutely correctly. And since you need to authenticate and authorize every single transaction, you're automatically in it. You automatically have a zero trust architecture. So therefore, from an audit point of view, from an external viewpoint of view, you have zero trust under zero knowledge. And because the L2 is a black box for everybody, you just have APIs into it. You cannot access data that you're not supposed to see. That's actually secured through multiple access layers. Even the operator can't do that. And you can streamline now complex workflows. Why? Because I can run multiple business processes amongst multiple organizations in the same execution environment, which means now I have direct interoperability between quoting, ordering, and billing. You have verified compute outputs, which means there is no, that everything was done correctly. Everybody approved it. Everybody had their data that they needed to share that was mutually endorsed in the execution environment and matched, which means you're good. You have automatic reconciliation, no more manual reconciliation, right? So that's automated reconciliation because it's a black box and it has the proofs on chain. It's secure and private. This is using standardized protocols, especially that's important for enterprises. There are billing, quoting, and ordering, for example, in the telecom space. Those are already now standardized processes with standardized APIs, which means integration becomes easy. I don't have to redo anything dramatically. If I already have, for example, in the telecom space, the LSO, the lifecycle service orchestration API is implemented for billing or ordering and quoting, I don't really have to do anything new. I just need to point it at a different environment to do the rather than directly to a partner, you point it to the environment. Everybody points it as is depicted here. The seller and the buyer just have APIs into the environment. the environment here is and what's currently being used is Linea, which as part of its architecture has a modified version of Hyperledger Besu. There are some to be some code changes made, but nothing outrageously dramatic. So that's the connection here to Hyperledger. So as I said, we have Hyperledger Besu within the zk layer 2 architecture. We can utilize private state exchanges with zk bridges, right? So I prove that the proof of correct execution can then be leveraged for initiating a state change here. So if companies want to have their different operating environments, as for example in telecom space, you have different groups of companies that want to have their own execution environment with no one else on it. You can utilize something like Hyperledger Firefly to create zk bridges between different implementations of the same stack, or it could be a different stack. There could be sort of Linea. It could be Era, or it could be Polygon. Works the same. They're all EVM compatible / equivalent. So bridging using Firefly, using the zero knowledge proofs that are being generated work just as well. So so again, just to reiterate, we have on the client, we have Hyperledger Besu. We're using zk bridges, leveraging Hyperledger Firefly. And that's it. Thank you. I just wanted to leave a lot of time for discussion, because I'm sure this is not a usual topic, and it's a different way of doing things. So want to hear people's questions, people's thoughts, feedback. That would be greatly appreciated. So opening up the floor.
Are you able to hear me?
Yes.
Okay. So is this kind of you have to integrate with existing ERP systems, or okay.
Yeah, you just need to do, yeah, you can it's just an API. So if you have SAP, you just use the API the S4 HANA API integration suite. So that's straightforward.
Let's say if there is no ERP itself in the organization, how does this work?
You have some form of inventory management, whether it's digital assets or real assets. You'll have some financial system where the ordering, billing, and settlement are recorded, because they have to be in the P&L, in the GL, because you have to report on it. So if you have multiple different systems and they're not in a single ERP, that's okay. For the different processes, you just utilize, again, the same type of standardized API. There's an there are straightforward SDKs that you can use with relatively normal access control using API keys. It's like think Twilio, just with a couple more lines of code, but not significantly more.
Okay.
right?
So,
The
sorry
goal
if
is
I'm
to make
asking
this,
you,
yeah, go
yeah,
ahead.
basic question. Like your product name is Linear, or you call it as Linear? Or, sorry, what is the
No,
product name?
Linea is the no, Linea is the zkEVM layer 2 stack that we're using, which is open source. We're just basically putting an enterprise wrapper around it
Okay.
and
So,
configuring it such that you don't need there's it's like zero fees and everything. So, but that's just pure configuration.
okay.
So they're standardized and in this case we are started to focus on the telco space. So there are now, like, for the different modules, there are now standardized processes, so they can be implemented in a standardized way for smart contracts.
Okay. So, would you be able to show us any uh, real business case for the telecom industry? How this system or your proposal
Sure,
will integrate? I mean, how does
sure,
it work?
sure, sure. There is so everybody has master services agreements between buyer and seller, and they have service level agreements. Telecom industry is not different. Um, and as with any other industry, when a service goes down, right? So if I have a service breakage, because in the telecom industry, for example, there's a data circuit that goes down. If it goes down too often or for too long, then um, the SLA agreement in the master services agreement hit, and you need to give billing credits, right, on the invoice. And that is, like, virtually every single time there's a dispute. Why? Is because the systems aren't synchronized. There's no mutual endorsed final state what whether an event is eligible for SLA credits or not. So what do? You put this module in between, and then you can go between buyer and seller, and you feed it uh, um, uh, ticket data, so service tickets, where the buyer opens the ticket in the service system of the seller and says, "Hey, there was an outage here. Here's the proof," and then goes back and forth, and then you come to an agreement, or there's a remainder, a delta between outage times. So what happens? All of that information, all of that data is fed into a standardized smart contract system, is recorded, and then is then automatically reconciled as soon as the ticket status is moved to close. Or, and if there might be a delta still between buyer and seller data, and that's okay, because in master service level agreements are master services agreements in the SLA section are agreements what happens, how to, if there's a dispute that can't be resolved, this is what happens. Like, you split the difference in the simplest case. And that is actually implemented. So you can implement these different types of automatic reconciliation rules in the contract as an extension module, or as an extension functionality. So you can upgrade or change or update the smart contract system with any new business rules that come along as the MSA changes. So that means the entire system is backward compatible, as it should be, and you can also configure and extend it as needed as new rules come up. And that is a concrete case. in the telecom space with participants such as, AT&T, Verizon, Sparkle, Arcast, and so forth, Holt, that are engaging in that, and we're talking about, billions of dollars that are in these disputes that are then settled after like 6 months or 9 months, and you need to accrue for all of that, right? So there's a significant amount of human resources that are utilized to reconcile this, and then come to an agreement that there is no reconciliation. And then these credits accumulate over a long period of time, and then you have very large balances or credits that need to be paid out. And that is a significant event on the GL, especially if you're a publicly traded company, rather than being able to close these things out quickly and fast, and therefore don't even have to accrue things, and then don't have large payouts. So what happens is you increase P&L. You're making it easier on your P&L in terms of accruals and in terms of cash flow. So it is overall a much better experience for the CFO organization. I hope I've been able to answer your question here.
Well, thank you. This is a good explanation on the business case from the telecom industry perspective. So basically, the current situation is there is a lot of back and forth handoff on the discussion about disputing themselves. There is no outage, there is an outage, this is an SLA, this is master level agreements that have been created. Now all this done through your system, basically, automatically.
We're just taking in the data as the ticket status, as the ticket statuses and everything is updated, right? So that is not taken away, because we don't typically, the companies don't have all their circuits fully instrumented in a way where the data can be easily extracted. They have to move towards that because what is now called network as a service. That is the latest trend in the telecom industry. So networks are actually becoming ephemeral. So I can actually create an entire network for just one event, like the Super Bowl, great example. That's one event where an entire telecom network is created, and it's highly software defined. And all the services are just for that a short period of time, and they all need to work, and they all need to be then, there's a quote, there's an order, there's a bill, and there's a reconciliation. Something happens there, that's not good. So you have these services going on all the time now, in real time. So you cannot afford, you just don't have the people to do these things manually anymore. So you need to have the data that is automatically compared against, it's like what happens inside of the network, what happens at the edge point, what happens at the last mile. So you can actually extend this, so it's not only between a buyer and a seller pair, like an enterprise and a telco service provider, but you're going into the entire wholesale supply chain between different wholesalers, because if you connect an office from New York and Singapore, you have probably 5 different companies at least in between. So you have 5 different SLAs, and you have 5 different failure modes in there that can, where something can happen. And in the end, you have to be able to hold everybody in that supply chain accountable. You can do that once everybody in that supply chain is actually on the platform, which most of them are all the big ones. So they're once they have one, they're there, right? So it's a whole ecosystem. Once onboarded, you can connect with all different partners, and that allows you to map out digital supply chains in a privacy preserving manner. So you can actually use cryptographic commitment schemes to commit to supply chains that are where SLA events are properly recorded and can be then basically shown that, hey, it was not my fault. Down in the supply chain, something went wrong. We don't know where it went wrong. We just know it went wrong between entity 3 and 4. That was an SLA event that impacted our service. So now you can start to structure contracts entirely differently. Because you're creating visibility into what matters while not revealing anything about the individual partners. So that's a significant departure from how things are going now, but it also now allows synchronization internally within a company between the buy side and the sell side that is typically siloed. That
so yeah, business case understood. How the so are you saying the contracts are all stored in Ethereum contracts? Is that what your diagram shows here?
You're mapping out the business processes that are defined in the contracts, right? So if I have an SLA agreement, then I have an SLA matrix, right, for different services, products, even down to the circuit level at times. So I'll take that and I'll implement that as a configuration in the smart contract system. If there is an automatic reconciliation rule, that's not a problem. I can configure that and then implement that in the smart contract system. If I want to have a smart contract system that is, not only between one buyer and one seller, but multiple buyer and seller pairs, I can do that in the same smart contract system. So now I have full interoperability across an entire digital supply chain while preserving privacy.
Okay, so I know you mentioned about the Polygon Ethereum, right? Here you're using the Ethereum as your smart contract, like storing your smart contracts in the Ethereum chain. Then where is
the smart contracts are not stored on the Ethereum chain. The smart contracts are in the layer 2 itself. They're stored there. It's a single node, right? So no company has to run any infrastructure. Like with private blockchain, there's no need for that, right? This is all. You have everybody agrees this is your operator, and if the operator screws up, we'll choke them, right? Otherwise, it's a black box, just like AWS works. Right?
Understood.
You don't have to do anything differently. What is different is that we are producing proofs of correct execution, proofs of correctness from the black box for every single operation, every single one. And these are aggregated into a single proof, and that is stored together with the hashes of the transactions as inputs on the public chain. Why? Is because we're inheriting security guarantees. By doing so from the chain, we can ensure finality of those transactions once the proofs are verified, because we know it has been done provably correct. And everybody can now look at the public chain. You don't have to give individual read and write access to the layer 2. Completely unnecessary. All that you need to verify that everything went on correct is publicly available, but does not reveal any sensitive information because we're using the proper cryptographic techniques, namely zero knowledge proof. Right? That's key. Which, by the way, ensures that you are also not prone to Gen AI cyber attacks on that. You know, by learning about business interaction, right? Which right now you do because you're doing everything over the internet, and you're connecting business A to business B. There are LLM models that are snooping that are learning about these things. With this in between, you don't. You just know that these businesses connect to that. What happens afterwards? Entirely black box. Right now, you're basically an open book.
Got you. Yeah, thank you, Andreas. And do you have any, to learn about this product, just go into the interview.co website.
I'm sorry, could you repeat that question?
To know about your product that you are building, or like interview.io, I should go in and check, or do you have a white paper or some document that you can share?
Yes, there's a. I'm happy to share. Happy to share the website should be live now. I think we're just launching the website this week, and there's also a product video on it, and yeah, so we have partners that we're working with in the telecom space, but again, not advertising our products here. We just want to say we're leveraging Hyperledger projects for real business cases in a way that, you know, overcomes all the challenges that private blockchains had. That's why they all failed, or are failing. It is a sensible approach that doesn't involve having to have tokens, or at least you can add tokens, obviously, if you want, on the platform, but you can do so now in a compliant way, because there's also zk compliance tech that you can implement as there. So that exists as well. So if you wanted to have a regulatory compliant decentralized exchange, you can do that.
Thank you. So you're utilizing the public chain here.
Only
completely,
only as the audit layer. The public chain is only the audit layer, right? That sees there's no leakage of business sensitive information from the layer 2 onto the layer 1. Layer 1 is just used for security assurance and transaction finalization, and the audit of the transaction. So by verifying on-chain the proof of correct execution, we've proven that everything on the layer 2 that no one can see was done exactly correctly and no one cheated. Imagine you could have a 10K or 10Q where you click on any number and you have a green checkbox, and that just means that you just verified that all the data, the entire data supply chain into that one number was verifiably correct. That's possible with it.
Thank you. Thank you.
Let me see. Do we have any question? Can you please hold on? Abhijit asked, can you please, sorry, I'm not taking this necessarily in order. Can you please elaborate on the zk bridges and why they're required? Yes. So I can. So the when you want to basically transfer data or transfer an asset, such as a bill credit from one execution environment to the other, right? I need to be able to verify that the transaction that caused the bill credit, or transactions plural, were done correctly. Why? Because I can't see into the L2, right, from the other. I can't see it. I have no way to know that everything was done correctly, right? So I need to take a proof that says, hey, by the way, this is the correct bill credit. Here's the information. Now you can use that. Now you can verify that zero knowledge proof of correctness on your L2, and therefore import the data with the knowledge, aka the bill credit, that this was done correctly. Right? But you need to do that in a privacy preserving manner, right? A. B, you need to do it you need to do it in a way that is independently verifiable without having to look into something that you're not supposed to look into. Hence, you need a what's called a zk bridge. So a bridging system where all the different bridge nodes are creating or verifying zero knowledge proofs that come from the target, from the source stack, going to the target stack. But they're verifying the proof, signing that everything was done correctly. That goes through the network. Everybody verifies that, adding their signature to the proof using, for example, like some signature aggregation schemes, so that is easily verifiable on chain, both the proof and the signatures of the nodes that yes, this was done properly. We have validated that. So that's why you need that, and you can facilitate that communication in a secure manner using Firefly. Abhijit, I hope that answers your question. I think Carlos asked, could you provide a practical applied example? And I think I did when we elaborated about the service level agreements. I hope that answered that question. Then Professor Kunjir says the architecture looks a little bit centralized. Absolutely, it is centralized. That's the whole point. I don't need a decentralized architecture, right? I only have consensus in a blockchain because I don't have a proof of correct execution. What are we doing when we're saying we have consensus? Like every single node that is part of the consensus protocol executes the same transaction and says, oh yes, by the way, I get exactly the same result as you other guys. Right? But you wouldn't have to do that if you produced a proof of correct execution. Why? Because the proof can't be faked. So I don't need 100 or 1,000 or 200,000 nodes. I need one. The only thing what I need consensus for is finality. Finality of those transactions where the proof has been verified publicly, and then I can say this batch of transactions that happen on the L2 are now finalized. Because you can't have finality until that proof has been verified, and you need to make sure that that is irreversible, you need consensus, but you just need the consensus on the layer 1, aka public Ethereum, not on the layer 2. I hope that makes sense. And Gary, I think I just answered your question, how private state is exchange. There is no private state. It's like, it all happens on the same node. It's like, forget what you have, the mental model of Fabric or Corda, or, you know, it's like a Besu. It's not. It is all centralized. Everybody's operating in the same execution environment. But no one can see anything. It's an entirely black box. So because it's a black box and I can't see anything, I need to be able to prove that everything was done correctly. By the way, if you have a private channel in Fabric, because you can't see into the private channel, all the other nodes need to trust that whatever happened in the private channel was done correctly. Which means you're taking on the entire business and compliance risk for all the private transactions that you're not seeing because you're replicating them around. You know, if you don't have a whole lot of money riding on that, that's okay. Once you have like 10 billion, 50 billion, 100 billion on your network, that becomes a completely different cup of tea. Oh, I'm taking on like $5 billion of business risk from like parties I don't even know about. Yeah, your chief risk officer is going to love that one. So Jim, you're basically saying commit from finality. Is that we're doing it the right way?
Yeah, I mean, a long time ago, I figured out that was the problem with most blockchains is they architecturally don't have the correct architectures for proper scaling, and those architectures already existed, and the key was just separating commit from finality.
That's right. That's why you have layer 2s everywhere.
No, more than layer 2 though. So I'll make up a term called layer 9. So layer 2s, for the most part, do have a set of, I'll call it optimizations that, to your point, have the correct assurances on chain to prove that the data is valid and the transactions are valid without sharing and making the transactions public, if you will, on chain, which is all true. When I look at the scaling problems, though, there's still scaling issues to deal with, for sure. But you're right, getting them off chain is one step or one part of that strategy to get really high scale where you need it. For some applications, many applications don't need that kind of scale, by the way. Only some do.
Oh yeah, it's all right. If you want to do so, if you want to do like high frequency trading, on an EVM, you can do that. You just need to do what's called optimistic execution.
Right, and that's another.
You're parallelizing that.
Is optimistic, and then the other mistake people make is they say, "Oh, well, you can't undo transactions on a blockchain." Well, that's never the issue. All you're doing is proving that they're accurate at the time they're made. The fact you can always make corrective transactions later and just prove those are accurate as well. But a lot of people sort of get confused on how to figure out transaction analysis and engineering on a blockchain.
That's correct. That's why we're taking this route to be able to, not only untangle the business process knot, but untangle sort of like the blockchain fallacy, right? I mean, Bitcoin was designed was designed for a very specific purpose. It must be slow.
And to your point,
that's by design.
Well, So the basic principle is and you hit it, is we have many different types of use cases. Each use case type has a different needs for engineering solutions. And you're 100% right that all of DeFi fits into a tiny box called, we only look at the world for this use case, which is why that use case doesn't scale or doesn't apply to 90% of finance, and certainly doesn't apply to things like supply chain where you're living. It doesn't apply to mobility. It doesn't apply to lots of things, to your point.
Right. And for most stuff, you don't need a blockchain. You need the proof of correct execution. Absolutely.
That's right.
And you want to be able to have, that verifiable and then say finality, right? So that's all you need, right? Gary, you said like central operator will have L1 cost and infrastructure costs. What is the revenue model to cover the operational cost of the L2 execution environment? Very good question. How does Oracle? What's the model for SAP and Oracle and Microsoft? They bill by module and seat. Right? We have the advantage that we need for most things. We need one environment. I can operate 1,000, 10,000 businesses in one environment. So in fact, my margins are as you scale up customers are significantly better than any of those ERP vendors. Jim, go ahead.
One thing to Gary's point about operators. So in the DeFi world, they always say, oh, we're in a sense disintermediating all of the existing financial intermediaries. In a sense, it's a revolutionary kind of thing. In reality, what we're doing is transferring a lot of that responsibility onto the exchanges and DeFi operators. But there's still a trust problem because you and I are not directly interacting anywhere. We're always interacting, quote, through a network of some type. And what's interesting is US DoD has finally figured that out slowly over the years. And they finally said, ooh, you know what? It's a problem. We can't just go to AWS or Microsoft and say, hey, our cloud, our, in a sense, network is going to run on one provider. So there is many issues with, in a sense, your network providers. The single point of failure all the way through end to end has to be analyzed. And then you have to figure out how do you make that fault tolerant across multiple service providers, which is not trivial.
No, it's not. It's not. I mean, in the end, what you want to do and what the L2s are trying to do, they want to quote unquote decentralize the sequencer, which is that actually is to Gary, to your point about order execution. It actually is it is not a problem. MEV is actually not a problem because you're not competing for a block. So when you do the when you do the block proposers are not the block proposal process is not incentivized by MEV optimization, right? Because you don't, it's just simply what comes in is the because everybody knows what the rule is, right? On public chains where you have block proposal where you have the block proposals or the block builders, block builders separated from the proposers, from the validators. That is where the MEV problem comes in, because now you have you're actually hiding information because you have private transaction pools. Right, and now you have now the ones that have private transaction pools have advantages over the ones that are using public ones. So in the end, right, it's everybody says just have a it's like in our case we just have one private pool, but we have all the rules published, right? And the rules is whatever comes in first gets process first. Done. Right? Very simple rule. And since you can't see inside, you don't know what the other transactions are. Right? And you can't bribe, the operator and say, "Oh, put mine first." No. Why? Because the sequence is determined based on the rule, and you can easily verify that is the case because the L2 transactions are the public inputs into the zero knowledge proof, or the hashes of them. So that's your and because you're basically, one of the commitments things is you're taking the hash of all of the hash transaction, right? Is you're based on sequence. So if you know when your transaction was processed and it's not in the right sequence, you're like, oops, nope, that's not cool, right? So you can always verify that everything was done properly. That's the key thing, right? And since we're in the enterprise world where you have contracts and you have operators that are doing that, basically have the gun held to your head, that you need to do things the right way, like AWS has. And there's we're not in a trustless environment, right? So I don't have the need for decentralization. And by the way, currently all the layer 2s, the public layer 2s, they don't have, except for Arbitrum Nova, all have centralized sequencers, and everybody's apparently quite happy with that. So why bother? That's right. The operator has to be credibly neutral. If not, then it's like the gun held to the head of the operator goes off. Yeah, I mean, you can run a consensus algorithm on sequence if you want. That's basically what's being done with shared sequencers and everything. The question is, do you need it? Jim, that's the question here. Do you need it?
Yeah, so it depends on the use case again. And I have use cases where I did not need to order the transactions at the time I committed them. I could separate that once again. So it's breaking apart what I call the transaction lifecycle to fit the use case, figure out what operations I actually need at a certain time. And in a sense, I violate what I call all standard conventions for what blockchain is all about by doing that. But I do fit a use case sometimes better.
Yeah, it might be true, right? So if there's no need for a provable sequence, that's fine too.
Yeah, because sequencing can happen sometimes after the fact based on the use case. That's all it is. So you have to look, like I had an AI use case mixed with a real-time analytics use case for Apple, and they were two completely different use cases. One needed, in a sense, not immediate, but within 120 seconds of a call ending, it needed to show up on a central dashboard. And the other one was an AI use case to optimize algorithms. So two different use cases, and it led to two different architectures on the data side to optimize the performance there. And one of them, the AI side, certainly did not need real-time sequencing at all.
Yeah, no, that's you. In fact, there you want to parallelize as much as you possibly can.
Yep.
Right. You want to break the training down as much as possible into the, and then reassemble the results, aggregate them up again.
Yeah, and so what I actually love is the fact that you took the time for your use case to think through in detail what that was and properly engineer it. Where the sad thing is 95% of what I see people doing on blockchain is, ooh, I don't do any real engineering for a use case. What I do is I just take what I call good best practices and then try to apply a set of tools to build my solution, which is horrific in my mind. But, clearly you've done something significantly different, which I couldn't emphasize enough. The approach is different, which is good. Thank you.
No, you're very welcome. Thank you for saying that. Really, really appreciate it. Yeah, we're doing that. We're designing that for the different set of use cases, and then if you have different requirements, then we're engineering towards that in terms of, do you need separating of private state? We have an architecture that we still have to implement in order to achieve that. You need optimistic execution. We have an architecture for that as well. In fact, there is actually open source code that we can leverage for that. So, but that is from a product point of view down the road, because we haven't hit those use cases yet. So right now, what we have works just fine for pretty much all the standard ERP processes, even across organizations. David, do we have any questions from the live stream? Guess not. Any more question? Glenn, great question. So the Besu code modification, that's open source. You just need to just go GitHub linea Besu, and it will pop up. So that code's open source.
Great. And thanks for letting me know that.
Yeah, so the as far as the detailed architecture, basically you have a sequencer, you have a prover, you have a synchronizer. So you have different. The whole architecture basically runs in Kubernetes with different services. We're currently, for convenience sakes, we're running on AWS, EKS, right. But that's, it's the standard stuff, like ALB with, Nginx, ALB, you have your IAM set up on the front, which is like, and then your in terms of access control, and you have then additional access control at the smart contract level, obviously. And in fact, we extended the Open Zeppelin access control libraries to make that organization specific. So organizations, for example, can be like MSAs. So you can organize access control and smart contracts around actual contracts if you wanted to. Yeah, so it's pretty straightforward. It's just you need to, it's like we're used like AWS, EKS, Argo CD. It's there's no magic there. It's just a whole bunch of Helm charts, with configurations, and you need some for the prover. You still need like a pretty beefy machine, like 90 plus cores, 512 gig RAM, shit like that.
Great. So are you going to? I've just checked your website, and I haven't been able to. It just brings up a password. But I'm saying, are you going to bring up more details on your website soon with your architecture ideas?
We'll share as we'll share more as we're going along. You can see it's like the architecture that we're using is no different than what what Linea does.
Got it.
Right? It's like there they also have encryption at rest. It's just we just put the right. Thank you, Sonal, for the update. So the architecture is actually already publicly available. It's just it is the Linea architecture. So
Right.
we'll just cross-link that. I mean, there's no magic. We just configure Besu differently, and so we have zero gas fees. It's already, everything is encrypted at rest, and we're just adding the appropriate access control on top of it, besides the proper access control at the smart contract level. That's it.
Okay.
It's really relatively straightforward. One of the keys, and the reason why is because in the telecom space, vendor lock-in is a big no-no. Like, super sensitive to that. So we're intentionally using all, like, our code is like open source. The only thing that's not open source, those secret sauce, are the ERP modules.
Right. Okay.
Obviously, they'll fully security audited, etc. But that code is then not open source, but is based on standards. So anybody who wants to recreate, there will be an open source version of the SLA module that we're using available, which is basically a quote unquote simplified code version. It does the same thing. It's just not, I would not run that in production, right? It doesn't have all the bells and whistles that our smart contract system has. It doesn't employ the updated or expanded diamond schema we're using. So it's not backwards compatible. It's not upgradable. It's not configurable, which is what we have. So we can configure our modules after deployment and ensure backwards compatibility. So if data models change, we can accommodate that.
Great. Actually, there's one more question. Do you know if there's, as I said, the integration of ERP together with blockchain is something that I think that more companies should be looking at. Do you know if there's a website or some community space where people are sort of discussing this whole concept and taking ideas further?
To be honest, I don't know. But it's like the way we're setting things up is to make it for enterprise developers incredibly easy to do the integration. Right? It's you can go into the it used to be called Web10 Pro space for SAP. It basically allows you to do external. You integrate. You can pull processes and conditional process execution from SAP out into APIs. So you have data going out, then the process pauses until data comes back in, and then the ERP process continues based on that data. And there are templates that you can use and that allow you to pull out the data from the SAP modules and then do a simple ETL and then integrate that into the SDK. Any SDK you want.
Great. Thank you.
So that effort is relatively, if you needed like a whole community around that, then something would be wrong. Right? Then you're making things way too complicated. Right? Our goal is to be basically like Twilio. Right? You have an API key, you write a few lines of code, you put that into an application that you integrate with whatever your backend system is, and you're done.
Hello?
Yes.
Hey, this is Mustafa here.
Yes.
I just main reason I'm here, I wanted to share a couple of ideas I have on the topic. First, thank you for discussing this very topic. I've been looking for some sort of community or something. Would be interested. Sorry about that. Would be interested in ERPs and workflows. First, to mention something about a personal project of mine I developed a couple of years now. It's blockchain specialized in execution of business models. It's a low-code, no-code. It executes standard BPMN BPMN model that you design using a standard tool, as if it were a smart contract. You draw the boxes, you assign them to people, you do the decisions, all of that. You enter data, and you assign the steps to people or other smart contracts. You still can integrate with Solidity code. But it was about the cold winter of crypto was about to start, so that didn't advance much. I got second place in Polkadot hackathon for infrastructure and tooling for that, but so little work that I worked on that since then. But I'm now looking into some other solutions. There are solutions now that develop something like standard application containers. You can execute any generic code, like a backend application code, like an RP server code, in a container, in a blockchain environment. It's called application targeted environment.
Yeah. There are different projects that are doing that. Yes.
Yeah, I'm exploring this. But anyway, this is as far as I found in that space up till I ran into your meeting now. So not with the intention of making anything complex or anything, but if there is like a community to discuss such space, making the blockchain more available to, I call it generic application programming.
I think the Hyperledger Foundation, I think I would have to defer to David for that. I think the Hyperledger Foundation would be an apt place for that type of discussion, I'm sure.
Maybe. I also looked, by the way, to integrating that BPMN execution with Firefly, but there are many steps, middle steps that need to be solved in order to fully reach a place where you can integrate fully with ERP systems, where you fully execute the thing in a decentralized manner. It's there has to be a community, and it needs to get a little bit complex and formalized and have some sort of standards for it, even if it gets people a little bit trouble. But we really need that.
I think there's you can do that Hyperledger. You can do it within the context of the EA. So if you want to develop standards there, so I think that's a that would be, in my humble opinion, the right place to try to create such a community.
Okay. Yeah. Thank you.
You're welcome. Absolutely. Any more questions before we wrap up? Don't want to. People have been very generous with their time already. So if we don't have any more questions, and again, I'm not seeing anything in the chat here, I can't see the live stream, then I would like to thank everybody. And thank you so much for attending and for the wonderful questions and the discussion. And reach out if you want to learn more. Get in touch. You can find Interweave on LinkedIn. Our website is going to be up very soon. And you can also reach us through Hyperledger. So David has all the thank you, Donald. Appreciate that. All good. It's actually interweavetech.io.
Okay.
So,
sorry.
Thank you, Eric. Really appreciate the kind words. Again, thank you very much for your time. And I hope to see you at one of the next meetups. Thank you again. Cheers, everybody. Bye.